Alright, this is just going to be a more in-depth video going through and explaining why I feel like this game cannot be modded. So this is Dead Rising 4. Basically it was asked by Larry, DJ Larry, if we could mod Dead Rising 4, because the game would be fun. I think maybe in their perspective, a lot of people disregarded the game because it was a bad game, and probably the modders kind of just hadn't paid attention to it, I guess. So I went and looked at the game, Dead Rising 4, and spent quite a bit of time writing a tool to actually start modding with the game. I got to the point where I had released the beta and I was prepared to test it in game, and so I had done that and discovered that the game would not accept any changes. I came to the conclusion that the game has a anti-modding system. It's actively checking for file changes and it's verifying it with the executable. The executable is large as hell. It's over 100 megabytes. And if you compare that to a game with the same engine, Dead Rising 2, the executable is only 10 megabytes. Actually, it's just 9 megabytes. So it's a factor of 10 times larger from Dead Rising 2 to Dead Rising 4. And you could say, oh wow, Dead Rising 4 is such a bigger game. This has much more stuff you can do in it. Why wouldn't it be bigger? But I think the reason why it's actually bigger is it's checking every single file. So every single file probably has a signature generated for it, a checksum to verify if there's any changes to the file. And it's probably checking each file and seeing if there's a change, probably actively, every time something is loaded into memory. And then on top of that, I believe they use Devidio or Devano, or I don't know what it's called, but it's an executable security on top of that. So they obviously wanted to make this game super secure and prevent modding on it. So this game you cannot mod. So I'm going to make this post on Entac's going to mirror this also on the Dead Rising forum. This is the Dead Rising forum. When I came here, I thought it was kind of weird because the Dead Rising 4 topic, which obviously was instigated in 2016, for over 4 years, nobody had really posted anything in terms of modding, which is strange, right? So under tools and tutorial, nothing. Under the modding section, no mods. Only people asking, can we mod? Help me mod. I want to mod. But no mods. I think the reason for that is because the game has security in place. Now looking at the game files, it's very clear that it's on the same engine that Dead Rising 3 is on and Dead Rising 2. And there's a spin-off called Dead Rising 2 off the record, so there's actually 4 games in the series. Now I don't know about editing for Dead Rising 3 because I wasn't a part of that. I worked just on OTR, okay? But it's very clear from the topics in these that modding was happening for these games, and then for nothing. Flatlined. Nobody has done any mods for this game since 2016, and I think the reason for that is because the game is protected. Now, can we get around this? Yes, no. I can't get around it. Personally, I think it requires somebody with advanced skills with disassembly and programming. They would have to go into disassembly, find out what routines are doing what, and then figure out a way to circumvent them, either by injecting code or replacing code in the executable. So it's a very complex process, which I doubt we'll ever see the likes of because the game is just not a good game. It's a horrible game. Right from its development all the way to its release, it's a horrible game. They missed the mark and it caused the studio to get closed down because it was just so off mark. And then even people quitting just before the game had finished releasing. So there's obviously some internal turmoil or problems happening behind the scenes that we don't know about, and the studio was dissolved. So you can see that in the game. It's just a horrible game. It's coded in a way that obviously they felt that they had to snub the fans. Obviously they thought the fans were the reason why they weren't making money. So why else put this protection here? It doesn't make any sense. The protection isn't against piracy; it's against modding. So it's a direct punch in the face to the modding community and the fans. So whoever was involved with this, I mean, they paid their dues. They lost their job, but there's probably some of these sneaky bastards still involved in the gaming community, and they're probably just as toxic as they were for this development for Dead Rising 4. They're probably out there infecting other IPs and games that you like and enjoy. So it's insane that there's these idiots out there in the industry today that are basically flourishing. And Dead Rising 4 is an example of when that gets overly toxic and causes the collapse of a studio. Anyway, I'm going to go over the testing methodology. This will be more technical and in-depth, make the video probably longer. And I'll go over that. You can be a judge for yourself on what's going on. So here's the executable. It's massive. If we look at Dead Rising 2, you can see it's just about I guess it's like 10 megabytes. It's 9 point something. Quite small. Fraction. What is that? Tenth of the size. Just insane. The data folder here. It's littered with archives. Even when you have something with a different extension, it's still an archive. So if I just bring this up in a editor here, I'm going to close all this stuff. If I can find that, close all. And I'll just pull in a random file. So this is a .big file, which is actually just an archive. We know this because we can see the signature. A signature is a pattern, a distinct pattern that's distinct from other files. So we have here a what they call a 4-character identifier code, which you can see the developer didn't really give a shit about because they just literally typed 6543 on their keyboard, which is ridiculous. But anyway, that's their identifier. We also call a magic number. It's basically just a number you pull out of your ass, is what they did. So sometimes referred to as a magic number. And it's always going to be the same on all the files that are the same. So this is an archive, and we'll see these that number on all the archives, as well as the rest of the signature. We get this file table, and we get a string table, and after that we get the data table. Data table can be compressed or it can be uncompressed, depending on what's being stored. From my tests, I think, this is a guess, but there might be a restriction on how much data can be uploaded into memory instead of the archive. So I think it may be around a megabyte, and if it's under a megabyte, they maybe store it decompressed, and if it's over a megabyte, I think they apply compression to it to get it as small as possible. I've seen these archives get up into the hundreds of megabytes. Some of them are compressed, some of them aren't. I'm not really quite sure why, so that's my assumption. Anyway, this is an archive, but we also have other formats in here, like .mdl, which we would assume is the model, but it is in fact another archive. Okay, you can see it starts with 6543, has that same signature as these items in the list, and then you'll have the names. It's an archive. So they use the same file throughout the entire game. They just give it a different extension. Another one is .text for the textures. As this is the same, it's an archive. Okay, so they just recycle this archive, and they just repurpose it or disguise it by giving it a different extension at the end. So somebody who's not looking at what's inside of it will just assume, oh, well, that's textures, and that's models, and that's stuff that's inside of stuff. That's the audio in the game or whatever. But in fact, it's just it's all the same thing. These are all archives. This also makes it very easy for them to apply a security measure. What they can do is this header here. It's relatively small, a fraction of the size, in fact. Like you could have 500 megabyte archive file, but only maybe a megabyte of that, or maybe less. A couple kilobytes, not a couple kilobytes, but maybe let's say 10 kilobytes of that file header. They're going to do a checksum against, and they can verify that something's been changed or not changed. They could have also done this another way and actually stripped these out and stored them into the executable, but that would have made it vastly more larger. So maybe doing a checksum on just the section of the archive would have been more convenient and faster. So I think that's what they've been doing, is just doing a CRC or checksum on a portion of the bin archive, and it would be super easy for them to implement because every single file is stored into one of these stupid archives, aside from the text files. There are just plain text files in here, which is silly. I have not tried editing a text file. I would assume that the game will allow you to do that, because those are just basic config files. But it might be doing that check too. As far as I'm aware, it's probably only doing this to the archive files, which is the majority of the game. Anyway, now I'll just go through my process. Actually, I think I'll explain the basic premise of the archive since I'm here. So if you want to follow along a hex editor, you can. I have this blocked out for convenience sake. These are just highlights, so I'll just delete two of these highlights because they're not going to make any sense. What's the table? Okay, so yeah, I want to delete the table, and there we go. Okay, so this is the header. It's very simple. They use 4 bytes as an integer, so it's just 6 bytes in the header. So we have the magic number. I think that's the address. Yeah, the address to the data file, which is where the archive stores the raw files. Then we get the total file size of the archive. And we get the file count. That's how many files are inside the archive. So there's 6. So we would expect to have 6 entries in the table. Then we have a pointer or address that points us towards the table. This is 18, which you can see here on the top column. 18 starts here. Okay, so that's the table start. And then it tells us where the string buffer is, or the string table. That's where all the file names are stored. So C, you can see here on the graph, well, not really much, but if we can use a jump command to just go directly to C, CO, and it goes right here, of course. That's the first name in the table. I don't know, dark matter m1.big. So that's how that works. So that's the header. Then we would want to read the table entries. So this is a entry here. You can see each entry going to the column here, and we should have 6 of them, which we do. 1, 2, 3, 4, 5, 6. Each one is, again, I think that's, what is that, 6 bytes? 1, 2, 3, 4, 5, 6, 7. Oh, sorry, 7 integers, or 28 bytes in length. The first one, I believe, is the address to the string or the name in the string table, which you can just follow. So that one would go C0, and that would bring us to here. Okay. The second integer is the hash code. So there's a heavy use of hash coding, which is another reason why I think that they're doing a CRC or checksum on the files, because this is basically what this is a checksum. This seems to pertain to the text here. I don't know why it's redundant, but if you change one or the other, the game will still load whatever is in here. It just ignores it, basically. So if I change this and not the other one, it'll load, but the game will just ignore it, and vice versa. So I think it's affecting this. Obviously, if it's affecting the data, that means I have to recalculate this properly to change the data, but that's definitely not what's happening. It's actually linked to the text. Okay. How I can prove this is pretty simple. Basically, we can run this through an algorithm called SMDM, and we will get this exact number. So that's how I know it's not data. Also, I can replace the data with a different chunk of data, and it will still work. So this is freaking weird. Okay, so let's say I take this file entry, and I didn't explain the rest of the table, did I? Let me explain the rest of the table, actually, and you'll understand what I'm talking about later. Okay, so we just talked about the hash code, right? That identifies the string, and then after that we get the size in the data buffer. That's how many bytes are stored in here for the file. So that's our retrieve size, and then we have the write size. So that's how big the file is when you store it on your hard drive, or you read it into memory or whatever. So this is your input size and your output size. In this case, you can see that they're different. So this one's not the same. After that, we get the address to the data chunk. So if we follow that, That's going to be 0120. That can't be right. 0120. There you go. Which is right here. So you can see that just after the string table, this is the data. Okay. Now, another way we can recognize this is we can see the beginning of a zlib header here, and just before the zlib header, we see the basically the output size printed right here. So you can see here, the output size would have been here, so it's 2D03, and over here it's printed backwards. It's 032D, and that's the output size. I don't know why they do it that way, but that's the way they do it. Then we can see the zlib header here. I had to verify the zlib header. I had read the zlib compression specification to understand that. There's also a summary by this guy on Stack Overflow. He gives us a little diagram, which I don't think is in the manual. Or maybe it is in the manual. Can't really remember, to be honest. No, it's not in the manual, so I don't know where he got it from. I don't know if he did it himself, or it's in a subsection that I missed. But anyway, basically the algorithm works this way. You get a header, which is what we were just looking at, the 2 bytes. You get a dictionary, I think, and then you get the compressed data, followed by a checksum of the destination file after everything was unpacked at the end of the file. So I checked all that to make sure that they were doing a legitimate zlib stream, and as far as I can tell, it's legitimate because they could have customized that on their end. But I ran it through the zlib compression library, and it didn't have any problems decompressing and recompressing. I also ran through another person's tool, Luigi's offzip program. I did both a compress and recompress with his tool. That's a different author and different source of different implementation of zlib for a different author. So if I had made a mistake, hopefully that would have been overridden by somebody else's program. So I tried their program and tried to compress the data stream with that. So as far as I can tell, the stream is all legitimate. It's just normal zlib, and there's not anything hidden in the data. It took me a long time to decipher all that, but I'm very confident that there's no hidden data in the stream. The ending checksum seems normal. The header seems normal. The few bits that I looked at seem to be normal. It seems to be fine. So I don't know why, if you recompress, the game doesn't accept it. Well, I think I know why now, but initially I was having a hard time understanding why it wasn't working. Okay, because everything should have worked. Everything added up. Now I believe firmly that they checksum the decompressed file, and they keep that checksum in the executable. So I'm concerned if you look at Gibbs' tool and you look at his hash function, he uses like db2m or something like that, which is a fast checksum algorithm, and it calculates the wrong checksum. Why would Gibbs use that? I don't know. I'm maybe concerned that maybe he recognized that in Dead Rising 2, and who knows what they're using in Dead Rising 4. They could have just used Adler, like zlib does, or they could have just picked whatever other ass and used that. It's just as random as anything else they've done here. Who knows? So it's really hard to understand if the stream that I'm writing back is 100% correct. But from what I can tell, I have. But yeah, replacing this stream will cause the game to crash, and I think that has to do more with the game's protection mechanism rather than a failure of understanding the archive. Okay, that's basically it. So like I said, that's the zlib stream. Oh, frig, I forgot to mention the last 2 things tonight. Okay, hash, input, output size, address of the data buffer, alignment. So if you look, we started here, which is on a multiple of 4, okay? Which means that's byte aligned to 4, and then we have the number 1, which means that it's compressed with zlib. It can be 0, which is raw, and that's important to note because I'll be probably demonstrating that in a bit. Okay, that's pretty much it. there's nothing funny going on at the end of the file. It's just straight up buffer. So the archive is super simple. Okay. So now that we've mastered that understanding of the format, that means we can do just experiments in a hex editor without the use of a program, even though I have written one. It's just more cumbersome and troublesome to make tweaks in there. Recompile it takes a while, and then you have to pass it in, and then you get an output, and then you have to check the output in the hex editor anyway to make sure whatever you did in code was correct. So just doing the changes in a hex editor directly really save time. So yeah. Okay, let's find my modding folder here. Alright, this is really messy. I apologize. First off, I need to make sure I didn't already do any changes to the files. I don't think I did. Or maybe I did. This looks smaller, so I'm going to delete this. And I think I made a backup in here. So I'm going to restore this backup. And I'm going to do a control test, just simply activating the game and seeing if it starts up. This file that I'm going to be modding holds the logo in it, so when the game starts it'll say Capcom, and then it'll go into Capcom Vancouver, and it'll show a second logo, so it's going to load 2 images in concession. It takes about 10 seconds for the game to actually boot up, which is actually kind of weird. We get Capcom, and it's going to go into the second screen. I don't know why it takes so long. It's still loading all these files, which makes me think that it's doing all these hash checks, which is very suspicious. And then I canceled it because after that, it just goes into the intro, and it's very loud. It's like boom, bah, 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 boom, and it's just like, holy fuck, what the fuck? If I remember, like the original Dead Rising, it just starts off and you're like, it's like very tranquil. You're just in a parking lot, it's dead quiet, and all you see is a mall, and you hear, and you see this guy walking towards the mall, but he's a zombie. It created an atmosphere, right? With this game, you started off and it's just like in your face, bam, 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 Dead Rising, da, da. And it's just like, what the fuck is this? Like, what am I playing? It's very loud, so I just control deleted that fucker because I don't want to hear that shit. Some people are telling me just to play the game because the game is awesome. I really disagree with that. But anyway, let's get off me ranting about how shit that game is. And we're okay. So I verified that the game starts up, no problem. So I'm gonna make a change to this file. Alright, here's change the file. It seems like you can change the header and it will accept changes to a degree. It seems particularly touchy with the data only. So this stuff, string buffer, table, you can fuck with. But as soon as you get into this, it starts to get, kind of weird. So just doing a test here. What do you call it? Okay, there's a window size, and I think I understand this right. Okay, so the bits are encoded in, I think they said octlets. I'm probably getting all the terminology wrong, but it compresses the bits, and so that means that your data might not compress into a byte. So this is not like translatable to a sector of data. It's not like that. It might be describing stuff in between bytes. So you might have to you have to decode all the bits. Anyway, the structure does accommodate for problems with the code. So we can run an experiment. We can actually induce a error, and it will crash the game. We can then account for the error by adjusting the checksum. So for example, let's find the data and highlight it first off. So I'm going to be looking at the first chunk, which will be described in the header here. So let's go to the address here, which I can just key in. So 0218, that's where it starts. We're going to go to the next one, so that's 324C. Okay, and that's where it stops. So I'm just going to grab the beginning and select the end of that block. Wow, I fucked that up. Like an idiot. Oh wait, I see that. That's why. Okay, so now I've selected this. In this hex editor, I can do a highlight, so I'm going to highlight this probably a little bit less bright, and that's the data first file. All right, so that's what that is. Okay. So now I should be able to actually calculate a checksum. Oh shit, I fucked that up, didn't I? All right, grab this address. Okay, and this is the checksum. This is padding for the next file. So this is the checksum here. So I can grab from here up, and I can do a hash, and I can do Adler, and it should well, it should have matched the output, but I forgot that it's the output that gets verified, not the input. So actually, that's fine. What am I thinking? Okay, so that's the Adler checksum for this thing, but this is the output for that particular file, which I'll demonstrate, which is I think I stored it over here, which is this one. So I'll just select everything, and I'll get the Adler for that. You can see it's DE 7F AF E4, which is probably what's down here. Yeah, it's the same thing. DE 7F AF E4. So it's the output thing. But anyway, I don't know. Anyway, this test is kind of iffy. But basically, we just changed one of these bytes to something else. I need to be careful here what I'm doing here. So header, and then I should be able to just change a single byte here. Alright, so it's just changing a byte. It's a little more tricky because it's a compressed stream. It works in what they call a bit window, just like a sliding window that works on a chunk at a time. And it's going to decompress that incorrectly, but it's not going to know that until it gets to the verification block, in which case it could choose to skip that and continue reading, or it could report that it's bad and again crash the game. But anyway, that's just going to be the simple edit that I'm going to make, and we're just going to try it. And this is just simulating just a simple file corruption for the game. Dead Rising 4. Alright, so in the control test, I didn't time it precisely, but about 10 seconds, and it loaded into the Capcom logo. So 1, 2, 3, 4. Okay, and the game has now self-terminated. Now I don't think it crashed because the compression returned, one of the blocks failed. I think it's a protection mechanism. I think the game it found out that I made a change because it checksummed the entire file, and then it forced a close. Crazy, huh? Alright, I'm going to undo all that, and we're going to do a different type of experiment. This is interesting. Right here is the input-output size, and then this is the address. Okay, I'm going to copy this, and I'm going to paste it over every single entry. Like I said, you can fuck with the table. It's just the data in the data buffer. Okay, so now I've done that. Essentially, what I've told the game is that this data, whatever the file is, that texture is now here, and this is now here. This is all here. So it's all pointing to the same block. This block. What's weird about that is the game will accept it. I think it's weird. And there you go. And then 10 seconds is going to... I'm not going to let it go any further than this because I don't want to hear that. But you can see that it's decompressed. The first file says startup blood splatter or blood spread. So it's just blood splatter. So it accepted that. Just weird, right? What else is weird about this behavior is I can replace this with the decompressed form, which is really weird and interesting. Alright, so let's look at the decompressed form. I can't remember if I decompressed these or not. Yes, these are decompressed. So this is the decompressed version of the file that I extracted with my tool. So I'm just going to paste it over top here. So simply what I'm going to do is, where's the data start? It starts here. Alright, we're going to select everything in the file down, and I'm going to replace that with a fill of zeros. Alright, so I haven't added anything to the file, I just filled it with zeros. And I'm going to overwrite, at this point, the raw, uncompressed file. Okay, and I'm going to give it the flag so that the header knows that the data is not compressed, so it doesn't decompress the file. As well as you need to copy the output to the input size because now it's not compressed, right? So it's reading it raw, so it's reading that size that was used to be on the output. Alright, that should be it for the test. So I can save this, boot it up again. And within 10 seconds it should load that splat up again. But we'll see. It's acting weird. You never know with this thing. You turn it on and you have to wait for a long time that you never know what's going to happen. Anyway, it loaded up. Okay, so I'm gonna close that. So that's really interesting. Okay, so let's just do a byte change. So this is just texture data, right? So these are just representing a pixel. So there's no real such thing as corruption, right? All right, let's type some numbers in here. So essentially, I just changed one of the pixels to like just some random color, like just one pixel. What? I didn't do that. The game crashed. It's just self-terminated. Okay, so this is a big problem. Okay, this is a decompressed file, a texture file. Each one of these, I think 32 bits, represent, because this is a what they call an alpha red green blue 32-bit texture. It's what they call raw. So that means, wait, what does that mean actually? Anyway, I think the 4 bytes represent the red, green, blue, and alpha channel. Okay, so when I overwrote, 4 of these numbers, that was me just changing a pixel. So I wasn't corrupting a data stream at this point. I am literally changing a pixel out of a million pixels that are part of this image. The game detected that, and it self-terminated. So there is definitely a protection, security preventing for modding. It's so disappointing because of the amount of man hours I poured into the application that I wrote to deal with modding, and just to find out that the game has this security on it. It's just very disappointing. As far as I can tell, there's no way to get around this. Unless we can figure out how to disable this on the executable side. So unless somebody has a source code that they want to share, I really doubt that that's ever going to happen. Is there anything else I can add to this? I don't think there really is. So this is the experiments I tried. It wasn't, I think I conveyed this pretty simple in the video, but this took me days and days to figure this out because this is just a simple test, but I was making broader assumptions and tests, and I really did think the problem was actually centered around my tool. I thought my tool was the problem. I thought my interpretation of the formats were wrong. It wasn't to the very end where I was about to rip my hair out. I just typed in a random number, tried it in the game, and I was really shocked to find out that the game crashed. Something simple as that should not crash the game. And so in this experiment, it was something just as changing a pixel color. That's insane. Obviously, there is a protection going on. The executable is massive. It takes forever for the damn thing just to boot, which means that it's doing a lot of checking on the front side of the loading. Yeah, that's what it is. And just for the shits of it, I will show you what the progress I had made with the tool. Basically, we have the archive formats here, okay, which are these things here. I wrote the tool so that I could unpack a big file, so we'll just take this one. I just renamed it to 444. And it just, you drag and drop it. You don't have to drag and drop it. You can actually double click and it brings up a selection window, and you can do that through here as well. But I just prefer doing drag and drop. It unpacks the folder and the contents of the archive. That works to repack as well. I can just rename those to 105.555, and I can just drag it into the application, and it just repacks it automatically. And I felt that that was just a convenient way of doing it. Now you don't have to drag and drop. You can interact with it. You can run it through command line, or you can drag and drop. It's flexible in that way. So it would have been a good staple in modding the game, I think. Now the .tex, the .text is actually in fact just an archive file, right? But I didn't want it to just be treated as an archive file. I wanted it to be more automatic. So I'm not sure if this one's modded or not, but I guess we'll find out. I don't have a folder here for it yet, so we'll see if it crashes or not. So if you dump this into here, yeah, it crashed. Yeah, I was doing some experiments, so some of these aren't actually functional, but let's just grab this. This says main menu. This is from the game folder, and this should be functional. Okay, and it's going to spit out where's the folder? Main menu, and it converts these into textures for you. So that's the what is this? Come over for the holidays, live, rising logo. It looks like it crashed on this texture. The problem is, yeah, it's crashing on this texture. Some of the textures are DirectX 10 textures. So this tool that I'm using is from 2007, and it only works with legacy textures. Now this was, I think, in my opinion, a bad idea on Microsoft's part, but with DirectX, which is a graphics library that Microsoft developed, they used a thing called Direct Draw Surface, which is a texture format, DDS, and they used the same format for decades. And I think around 2012, they had revamped everything. And they had redone the DDS file to be a completely different format. But the strange thing was they didn't change the extension. So it would have made sense to me if this was called, I don't know, DirectX DDS X for 10, DirectX Draw Surface 10 or something like that. That way it's a whole new format, right? What's weird about it is they kept the same extension, and now it's just you have a bunch of textures that are just not compatible now with tools. Actually, wait a minute, that just loaded up. That's weird. Well, whatever. Okay, well anyway, some of them work, some of them don't. I'm not sure why the thing was crashing and now it's not. Maybe it was opening a different file. I don't know. Whatever. And so of course it works for repacking. Just call this whatever. 444. Drag it into the application, and then it should create a whole new texture file for you. So it was just meant to be a very simple way of doing things. Now, also, if some archives, you might notice that the .big actually contains .bct, and bct is actually what's inside of the .tex. What I do is I automatically convert them on the fly to .dds. So what I just did to make this more convenient was same thing. If you want to convert a BCT to a texture, you just drag it on, and it creates the relating DDS, and vice versa. You can take a DDS directly and just throw it into and it just creates a relating BCT. So this was getting into a spot where I thought they would improve the modding capabilities, and I was just about to get into the models too. The models are a more deeper format. Okay, so I was actually collecting and discovering and hoarding a bunch of information from other people, and I was just about to get into that section, and I felt it was important to do a beta test of the tool to see if it was functional. And when I had done that, and it was pretty late in the game, mind you, because I had already implemented several of these functionalities by the time I had tested it, and I was shocked to find that it doesn't, the game doesn't allow mods. So this is just really a waste of work. Really disappointing. Um, if anything, it gave me a chance to uh, play with the zlib compression and implementation. So that's the only takeaway I can get from that. But other than that, it was a huge loss. So it's just it's really depressing. Anyway, I'm gonna delete all this stuff. That's great. Save myself some space. I have so many files in here. Just gonna delete it all. It's horrible. But anyway, that's my overall breakdown of what's going on with the game. In case people are skeptical of my claim, I think it's very clear that there's some protection going on. I'm a little bit concerned about my scientific method here, but going at a raw file, it's odd that you can load it in the first place, and then even more odd that you can't even change a single byte on it without the game detecting it. So yeah, but also with this experiment, it tells you specifically it's somehow doing a CRC or checksum and verifying it with the game. Now I haven't tried the, anyway, I did try this. Yeah, I tried putting a different file here. It doesn't work. So I don't know really how it works. So I must link this hash code with this hash code or this checksum. That's most how it verifies it. So somebody could check the executable for this number, and the number probably after or near it is probably the one for this file. I can check it right now, but I think the executable is protected. Yeah, I'm not even going to try. It's protected, so it's going to have all the data scrambled anyway. Alright, I'm sorry for the long video, but hopefully this kind of settles the question of why can't we have modding for Dead Rising 4? You programmers are too lazy. You guys need to make modding. Question I always get asked about, making tools for 4 over the several years that it had released, so I think this is a definitive answer. No, we can't. So modding is dead for that game. That game is dead. That game's dead to me, and it should be to everybody else. Horrible game. From code to playthrough, they just want to say a big F you to the fans. So yeah, don't bother with the game. They make it clear to Capcom that it's a game that shouldn't have existed, and they will put better effort into the next game, like Dead Rising 5. So don't settle for shit. That's one of the problems with the gaming community. They settle for shit, and then you can keep feeding, the devs keep feeding you shit, and they think you like shit. It creates a toxic environment for the communities, so you really need to stand up. Boycott stuff, bitch about stuff, post stuff. Don't accept anything better than good quality products. Um, don't give the industry the wrong idea, because they will milk you for every freaking dime and dollar you have and give you shit for it. So yeah. All right, that's a long rant. Take care. See you in the next one.